Welcome to day 2 of Unit 2. So the first part is review, and we're going to identify the domain and range of the following functions. And now we know what type these functions are. So when I look at 1 through 6, we're going to have linear, exponential, and quadratic. So let's first focus on the two linear functions. So remember, those are represented by a straight line when I look at a graph. And so for linear functions, for domain and range, there is no restriction on what the x's are. So my domain is negative infinity to infinity, because remember in the x direction, there's no restrictions, as well as my range. So I'm going to fill that in for my two linear functions. Okay. From there, we can look at let's go to exponential functions. So exponential functions are curves, and they're represented in example 2 and 4. And so as you recall, the domain, again, my x values have no restriction as I go from negative infinity to positive infinity. So my domain is still going to be negative infinity to positive infinity for both. Okay. What does change is our range, so we always have to be careful about our range for exponential functions. So remember, we always go min to max. So on example 2, my minimum is the location of the horizontal asymptote, which in this instance is 0. So my minimum y value is 0, and it's an asymptote, so I'm including it, or I'm sorry, not including it, so it's a parenthesis. And so while my min is 0, my max is positive infinity. Again, there's arrows at the end. I added those, but means the graph goes on forever in the positive y direction. Versus, if we look at example 4, my minimum value from the y direction is negative infinity, and it's going to max out at the location of the horizontal asymptote, which is negative 1. On these graphs, it's hard to see. I drew it in at negative 1. We'll get more precise later on, but it's the idea that for exponential functions, our range is affected. This number right here, the min or the max, is affected by the location of the horizontal asymptote. And we have two examples of quadratic functions. Remember, those shapes are recognized because they're parabolas, and they have a maximum or a minimum based on which way the function opens. So again, our domain, there's no restrictions on our domains, but what does change is our range. So in example 3, it opens down, meaning my minimum y value is negative infinity, and it goes to my max y value right here of 1. Now, opposite or different than exponential functions is I have a y value. This is the 0.01. So I'm going to put a bracket because it includes it. Same for example 5. My range, notice my minimum now is my y value. So this is the 0.1, 2. So my range is going to go from 2 to positive infinity because my graph opens up. Okay, so that summarizes the domain and range of the three functions we're going to study in Algebra 1. So in Algebra 1, a function can be represented 4 different ways. And we're going to move between these different representations. So option 1 is it can be represented as an equation. It can be represented as a graph. A function can be represented as a table of values, or a function can be represented in a word problem. Okay, so now what's going to happen is we're going to provide you some given information, and we're going to complete the missing representations of the function. And we're also going to start learning how to graph. So here we go. Example 1. Let's look at this guy. When I am given an equation, okay, I should be able to identify the type of function. And when I look at this equation, I see that my highest exponent is 1, so it's going to be a linear function. What that does is it also tells me in my mind, when I graph it, it's going to be the shape of a line. So let's complete the other parts. Let's graph it. Let's complete a table of values. So I'm going to show us 2 different ways. The first way is going to be using the Desmos app. Okay, so this is a free graphing calculator. And so I'm going to type my graph in here on the left. So I have y equals, or you could type f of x, it's the same thing, negative 3x plus 1. And I have my graph. And you can zoom in by pinching. Okay, you can also get the table of values. So if I click the gear, so notice I click the gear and I click the table of values, it's going to provide us the table of values. So I'm going to take these and transfer them back to my graph. So when x is negative 1, y is 4. When x is 0, y is 1. 1, negative 2, 2, negative 5. Thank you, Desmos. So we're going to plot those points. In your note packet, you should be graphing these with a straight edge. I'll do my best. It should go through all 3 points, and so we have our graph. And then I can also identify the domain and range. The domain, we know for linear functions, is always negative infinity to positive infinity, as is the range. So again, let's go through those 3 different representations, or 4, or 3 in this case. We have our function, which helped us find our table of values by using Desmos, and it helped me create a graph. We can also identify and graph a quadratic equation. So let's look at this guy. So how did I know it was quadratic? Well, I knew it was quadratic because in the equation, the highest exponent was 2. So I know right now I am visualizing a parabola when I graph it. So I'm going to also show you how to do it on your graphing calculator. Okay, so on your home screen, it should look like this. So what we need to do is you need to hit the y equals button, which is above the second key on the upper left corner, and it's going to take you to a y equals screen. Again, remember f of x is the same thing as y. It just communicates that we're actually talking about a function. So I'm going to type the x key. X is to the right of the alpha key. Squared is on the left-hand column, 1, 2, 3, 4, 5, 6 from the bottom. And then I'm going to type plus 1. Again, the keystrokes are in that box. Okay, and I want to graph the equation. Let's just see what it looks like. So I'm going to press the graph key, which is in the upper right corner. And there we have our parabola, which is great, but we don't want to sketch. We want the exact table of values. So to make a table of values, as it says in the box, we're going to press the second button, which is the blue button on my calculator screen. And then we're going to press graph again, which is going to activate our table of values. So in this instance, again, I see my table of values of negative 2, 5, negative 1, 2. So I'm going to use that to fill in over here. 5, 2, 1, 2, 5. Okay, so again, we want exact values from the table of values. So thank you, calculator. We're going to go back and plot these points. And again, remember there's symmetry, so plotting the right side should be a little faster. It's a like soft U as I connect the dots. Okay. And so now my domain, again, negative infinity to infinity. My range, my minimum y value is 1. My max is positive infinity. And so that's how you can graph on your calculator. So for example 3, we're going to give our function, and notice on example 3, we already have a given table of values. So I look at my function and I realize my exponent is x, which tells me I have an exponential function, so it should be a curve. Now I am going to show you just what it looks like on our graphing calculator just so we learn keystrokes. So I'm going to press y equals. If there's anything there, you could press clear on the right hand side, and I'm going to type 2. Now the raised to is on the right hand side. It's like an upside down V. And then I'm going to type x. So it should be 2 raised to the x. Okay. From here I can hit the graph button. And so I know that's what my curve should look like. Okay. It should be increasing. So here we go. So I know my type of function is exponential. And again, I know that by just looking at the equation and realizing my x is the exponent. The table of values is provided for us, which is great, which means I can just plot those points. So we're going to zoom in a little bit, negative 2. And when we get the fractions, we're going to we can approximate -1/2, 0, 1. Okay, it's going to be a soft curve, so it's going to look like that. We're going to draw arrows at the end. We're going to not cross over the x-axis. Okay, and our domain again. And let's look at our range. Our minimum value is 0, and my maximum y value is +infinity, so that's my range. Again, range is min to max. Okay, so again, when I look at this and see that x is in my exponent, it tells me that I'm going to have an exponential function, and the graph should be a curve. Okay, so the last one is a given function. When I look at this guy, you should notice that the highest exponent is a 2, which tells us it's a quadratic function. That tells me it should be in shape of a parabola. When I look at the table of values, I do need to fill things in, so I'm going to use Desmos for this. I just keep alternating back and forth just for fun. Okay, so I had the graph, so I'm going to X that out so you can clear things, and I think we had the graph y equals -x² plus 2. I will also show you if I typed f of x, it'll do the same thing. So f parenthesis x equals, what would we say, -x² plus 2. Notice it's the oops, got an arrow out. Exact same graph. So whether you do a y equals or an f of x, I used y just because it's a shortcut. Okay, so my graph opens down, which is interesting. We haven't seen that. If I want the table of values, again, I'm going to press the gear in the upper right of the box, and I want the table of values for the top one. So there we go. So we have -2, -2, -1, 1, 0, 2. And I know there's symmetry, so that when I go back to my notability, it should be fairly easy to type in. Oops, that's not right. This is going to be 0, 2, -1. Go back to Desmos really quick, make sure that's correct. -2, 1, 2. Whoops. Okay, so we're going to make that a positive. Okay, thank you, Desmos. And so we're going to plot this. Again, the graph on Desmos told me it opened down. Remember, we should be plotting these exact points that we get in our table of values. Range, so when it opens down, my minimum is -infinity, and it goes to a max value of 2. Okay. Again, what's interesting to point out is it's always located, it's called the vertex, right? This point right here is our maximum or our minimum. It's the vertex, and that's going to be the max or minimum y value of our range. So at this point, you should be comfortable typing equations in either on your graphing calculator or Desmos, getting the table of values, and using that to plot exact points on a graph.